Good morning, everyone. As Sashko said, my name is Andrew. I'm the head of engineering at a company called Boost. Just the elephant in the room, I'm 7 feet tall, so hopefully you guys won't ask that again. Like I said, I'm the head of engineering at Boost. I'm from Austin, Texas. I'm very much an open source nut. I have been doing open source software since I was in high school, so it's kind of always been my thing. I'm the maintainer, contributor, and janitor for several Node.js modules, including debug, progress, micro lock, and Apollo errors, and a few others. And I think I definitely enjoy systems and backend programming more than anything. I endure the front end, but I like things that are a little bit more discrete and predictable. So what is Boost? Boost is a career coaching platform powered by a mixture of industry experts and machine intelligence. We provide you custom tailored advice, so you can send Boost a question like, how do I navigate this difficult political situation at work or not? And through a mixture of industry experts and machine learning, we kind of provide you with custom tailored responses to those questions. We switched from RESTful APIs to GraphQL about 7 months ago. So this presentation is just a little bit about what we've experienced and some patterns that we found on the server work really well for access control and error handling. Okay, so first impressions when we started working with GraphQL. It feels kind of like the Wild West, but in a good way. Kind of like when Angular 1 or even Node.js first launched. Everyone has their own pattern for pretty much everything, and there aren't really a lot of the standards are still emerging. The community does feel very high energy, kind of like Node.js when it first launched, in that everyone's really excited and everyone's working really hard to sort of make GraphQL more mainstream. And the people who are using GraphQL seem to be pretty optimistic and enthusiastic about its future. And like I said, best practices are still emerging. So teams kind of require a certain level of grit and curiosity from those making the switch from RESTful APIs, for instance. So why did Boost switch to GraphQL? Well, first of all, we had a huge set of RESTful API endpoints. I think we had close to 90 or 100. And it just kept growing with every time. Every time we wanted to iterate on the product or slightly adjust it while we were trying to find product market fit, we had to either tear down a bunch of existing endpoints and rebuild them for a new use case, or we had to add new endpoints. So it was just kind of an ever-expanding surface area on our API. And we wanted to be more productive with less code. Writing RESTful APIs, you tend to write a ton of code for every little use case that you have. If you're doing a strictly resourceful REST API, no one does that. You would be requesting one resource and then another and another. Maybe if you're using something like JSON API, you're able to specify relations that you also want to load with a resource. But it's slow. You're making in requests for in resources usually. So we wanted our new API to be incredibly fast, especially on mobile. As was mentioned before, GraphQL performs insanely well on mobile because you're making one request for pretty much all the data you need. And we wanted to spend less time thinking and more time slinging product. We don't want to have to solve hard engineering problems or figure out how to reinvent the wheel every time we want to build a new feature. And so sometimes coercing REST to play nice with complicated business logic needs can be challenging. So why didn't Boost switch to something else? gRPC, which is another typed sort of API-esque system. It only works server to server and native to server because it requires HTTP2, and most browsers don't support that yet. And I don't know anyone who uses Falcor. That was another alternative, but I don't really think Falcor is getting a lot of traction, and really nothing else looked promising. So our primary concerns, and I think these are also concerns with most people switching to GraphQL, are how do you handle access control, and how do you handle errors? With a REST API, it's simple. For an error, you return a status code and you return an error message, right? And that works great because in a REST API, requests are not multiplexed. You can't send multiple queries down on the same request and expect multiple responses back. And likewise, you can't send multiple updates, if you're doing it properly anyway, and expect multiple update responses, right? So GraphQL has a bit of a new requirement there. So of course, this is kind of how most people write REST APIs. You have middleware that handles access control and request preconditions, like should this user be able to access this, what state should be loaded before it gets to the route handler, etc. Usually you have some form of afterware, which is just if you throw an error, how do you format it on the way back out the pipe? Or if you want to coerce a response into a certain format based on the route, afterware is useful in those cases. You have a route controller, which is usually single purpose. It receives a request, it interacts with the model, returns a successful response, or throws an error, right? And then you always have a data layer. And everyone has their own way of doing data, right? Some people use the same service, like a massive monolith application, in which case you have models and service objects. Or some people use separate services, so like a microservices architecture, in which case you're using something like gRPC, HTTP, or some other transport to interact with other services running on your back end. So it kind of looks like this, right? Fred makes an HTTP request. It goes through middleware. It hits the route controller and interacts with the data layer, and then a response is rendered back to the client. So GraphQL doesn't have middleware or afterware. It only has resolvers. Resolvers' responsibility are to bind portions of a request to functionality in the data layer. So what is this user requesting based on the query, and what do I do in order to get that data? And the data layer, again, is pretty much the same, right? You can use models and connectors, or you can use different services. So it looks more like this, right? Much simpler. Fred makes a request, goes to the resolvers hit the data layer. The challenges with this pattern are that access control must be moved from middleware to either models or resolvers. GraphQL allows the client to dictate what they want to load, and with a REST API, you don't really have to worry about that, right? Your route controller is usually only responsible for doing one thing really well, right? With GraphQL, you can sort of traverse down your data however you want. And that requires complicated access control rules. And like I said before, requests and responses have to multiplex. You could do something like query batching where you're sending, up 10 to 20 queries in a single request. And that means that every single request needs its own error state, if applicable. It needs its own response. So you kind of have to figure out how to handle that on the client. So status codes don't work. You can't say that the user's not authorized for a query if there are 10 queries coming back, because 8 could be authorized, which means you can't say, like a 401, because which query was not authorized, right? You have to be explicit as to which portion of the GraphQL request encountered certain error states. So our solution, access control and last-ditch error masking is handled at the resolver level through chaining. This is not exactly how Facebook recommends you do this. Facebook, I know a lot of their main recommendation is that you put access control rules in the model layer. And that's great if you have multiple API types interacting with the same data layer. We do not. We only have a GraphQL API. So putting it in the model layer just is making the model layer even more of a God function, right? So we decided to split up access control rules and put them in the resolvers. Also errors, we decided to present them in this standard errors array that comes back with every GraphQL response, and present the errors in a consistent machine readable structure. So what does that look like? Let me pull up in some code real quick. Well, hopefully. Cool. So just as a little demo, we have a GraphQL server and a schema where we want to be able to register a user, update a user's profile, ban a user, and get a user, right? So we have 3 different authentication states right now. We have I'm not authenticated, we have I'm authenticated, and we have I'm authenticated and I'm an admin, right? We don't want non-admin users to be able to ban a user, and we don't want users that are not logged in to be able to update their profile or get their user, right? Likewise, we probably do not want a user who's already logged in to be able to register, right? That doesn't make any sense. So, as per the typical Node.js server setup, we use Express. We hook up GraphQL with a piece of middleware called GraphQL Express. I don't know if anyone in here uses Node.js for the GraphQL API, but GraphQL server is a really great tool, and that's what we use. And we have a few errors, right, for our different error states. So we need an unknown error in case something on the back end craps out, right? Like if the database disconnects or something, we don't want to tell the end user that the database died. We want to mask it with an unknown error. Likewise, we have an error if the user is not authenticated but needs to be, to handle that state precondition. We also have an error if the user's already logged in and they're trying to register again, for instance. So an error that we present if the user's already authenticated and they're doing something that they shouldn't unless they are not authenticated. We also have a forbidden error in case the user tries to ban someone and they're not an admin. So then in our schema definition, we import our errors and we provide a few base resolvers, as I like to call them abstract resolvers. And abstract resolvers are useful because we can, in a single place, define state preconditions that must be met in order to run certain routines on our resolver layer. So let's take banning a user, for instance. The client makes a GraphQL request, which is a mutation, saying that they want to ban a user. The first thing we do is verify that the user is authenticated. If they are not, we immediately throw an authentication required error and we stop. But then we check to see whether or not they're an admin. If they are not, we throw a forbidden error and we stop. Otherwise, we unleash the ban hammer on whatever user is selected. So we provide first a base resolver that handles the case of something crapped out and we don't have control over it. So our base resolver checks that whatever error has bubbled up to it is an instance of an Apollo error. If it is not, it masks the error with a new unknown Apollo error, so that the client isn't told that the database crapped out, for instance. And we, as a convenience, attach the name of the original error onto the data property onto the new Apollo error. So Apollo errors look kind of like this in the response. So this is a standard GraphQL response. Clearly, if the user is attempting to request, if the user is trying to load their own profile and the database craps the bed, for instance, we present that masked error. So it gives us the string that we defined in the error, an unknown error has occurred, the name of the error so that it's machine readable on the client and the client can react appropriately, the time that the error was thrown in case we want to programmatically handle that, for instance, and then any sort of metadata that we want to attach to the error. In this case, we're assuming that it was a database connection error, and we're attaching the name of the database connection error to the error object. So that's presented here. So on this base resolver, we're going to create a few more preconditions. The first is an is authenticated resolver, which will handle the precondition that the user is authenticated who's making the request. And you can see here, oops, typo, that the is authenticated resolver is spawning itself from the base resolver. So what that means is that when requests come in, they're going to pass through the base resolver first before they get to the authenticated resolver. And if errors are thrown down the resolver tree, those errors are going to bubble back up to the base resolver, and the base resolver is going to inspect the error and make sure it's an error that we actually wanted to throw. So then we also have an is not authenticated resolver that also spawns itself from the base resolver. What that does, and I didn't really go over this one first, the is authenticated resolver, of course, checks to see if the user is attached to the request context. And if it's not, it throws an unauthorized error, right? The is authenticated resolver checks to see if the error is attached, and if it is, it throws an error, because we don't want to register or do an action that requires authentication if the user is already authenticated. And then, of course, we have an is admin resolver. The is admin resolver establishes the precondition that the logged in user is also an administrator. So you can see here we spawn the is admin resolver from the is authenticated resolver. And that's where we get this look right here. So the request comes in from the client, again, it hits GraphQL, it goes through the is authenticated resolver, then it goes through the is admin resolver, and then finally it gets to the ban resolver, which is down here. So the ban user resolver spawns itself from the is admin resolver. So by the time it gets to this resolver, it will have already checked that the user is authenticated, and it will have checked that the user is an admin. And then our ban user resolver does whatever work it wants in order to accomplish that goal, right? Likewise, for registration and login, we spawn that from the is not authenticated resolver, because we don't want a user trying to log in or register when they're already authenticated. And of course, updating the profile and getting the user require the authentication state. So they spawn themselves from the is authenticated resolver. So, I know it's a little complicated, but we found that this is a really great way, once you kind of grok that requests bubble down the resolver tree and errors bubble back up. It's a great way to both handle like error masking and error transforms, as well as ensure that certain state conditions are met before requests are allowed to sort of like interact with your data model. So we spend very little time now thinking about access control. If we need a certain like access control precondition, we just create a new base resolver and we inherit from it, and for every single case where the user needs to be in a certain state before they're allowed to make a request. We also don't worry about GraphQL errors leaking back to the client. We found that one of the most common questions that I've seen in like Slack or on Stack Overflow, for instance, is like, how do I make sure that the error that goes back to the client doesn't say there's a typo in a GraphQL function, or that there was some error thrown internally by the backend. And what a lot of people end up doing is they write lots of try catches in their resolvers, and they transform the error if they don't like it. So if they don't like that this error is a database error, they throw some other error. And this allows you to sort of do that in one place rather than doing it all over the place. So we love open source software. As I kind of stated before, I'm a big believer in it. And the Apollo community and the Apollo team have been very supportive in us making this transition to GraphQL. So we released both packages as open source software, both Apollo errors and Apollo resolvers, so that other people can avoid having to deal with some of these initial questions when they're spinning up a GraphQL server. So yeah, that's pretty much it. Wait.
We have time for like one question if anybody has a question about this type of approach. Questions? All right.
Can resolvers be asynchronous?
Yeah.
The question was, can resolvers be asynchronous?
Yeah, so the resolvers wrap everything that's returned in a promise.resolve. So anything that, if it returns a promise and the promise rejects, it throws, right? If it returns something synchronous, it's also treated as a promise.